This is activity one, and we're going to calculate probability by using combinations. So combinations from last lesson is going to be used. We have some three choose two sort of scenario. What I want to discuss is the same story from the getting started. Walter is consistently making 2 out of 3 free throws. And I thought it'd be important to list that as a probability statement. Probability of make is 2/3. That also does mean that the probability of miss would be 1 minus 2/3 because he's guaranteed a 100% chance of doing something. He's either going to make it or miss it, and he makes it 2/3 of the time. So 100% take away 2/3 is the probability that he's going to miss it 1/3 of the time. Okay, with that in mind, he's shooting 3 free throws this time. Determine the probability of the following events. What is the probability of Walter making 0 of 3 free throws? And leading into this lesson, I took the time to go ahead and make a list of all the possible scenarios that outline what Walter's going to do. Walter could make one when he makes it on the first, or he could make 2. He could also make 2 if he's missing in the middle, or he could miss the first and then make the last 2. So that's 2 makes. Or he's got miss, make, miss, or he's got miss, miss, make. Or he makes all 3, or he makes none. And so this is the outline of every single scenario. And it's a little out of order. My brain finally kicked in about halfway through, like, oh, yeah, if I did it systematically by moving and shuffling in this way, focus on how many makes and put them in a group, that was when I finally was like, okay, now I know how to shuffle things. So this is scratch work. And if I'm going to show you officially, I'm going to redraw it where I put all the makes first, the 2 makes next, the 1 makes, and then finally the no makes. But with that in mind, there's only one way that Walter's going to make 0 out of 3 free throws. So we just calculate that probability. 1/3 times 1/3 times 1/3. 3 to the 3rd power is 27. So this is 1 out of 27. Not likely. Probably gonna hit. What's the probability that Walter makes 1 out of 3 free throws? So that is the make, miss, miss situation, or the miss, make, miss situation, or the miss, miss, make situation. But there are 3 different ways that he could do that. So that's what I'm showing here. Miss, make, miss, make, miss, miss, make, miss, or miss, miss, make, I mean. So of those 3 ways, these all have the same probability. There's 2 miss probabilities in there. There's 1 make probability in there. So when I outline it, I just need to make sure that I have all the fractions. So I have 3 of them, but there's a 2/3 chance that in the scenario he makes, and there's a 1/3 chance and another 1/3 chance because he's gonna miss. Now, multiply across the top. And this 3 on the outside, if it helps, you could put it over 1, so you realize it's the 3 that goes across the top as well. 3 times 2 times 1 times 1. And then on the bottom, 1 times 3 times 3 times 3. Don't make the mistake that some of my students do, and they put 3 on the bottom as well. This 3 is technically 3 over 1. 6 out of 27 reduces down to 2/9. Okay. There's a 2 out of 9 opportunity, about 22% of the time. What is the probability that Walter makes 2 out of 3 free throws? So he's making 2, missing 1, so there's 3 ways that could happen, right? We outlined it. He could make, miss, miss, make, miss, make. What I'm showing here. So there are 3 ways out of 1, if you want to make it into a fraction, where he's going to make, and miss. And it doesn't have to always happen in this order, but it's going to be the same probability, even if this order is shuffled, because you can just shuffle multiplication. So 2/3 times 2/3 times 1/3. I'm going to right now reduce the 3 that's on the outside with one of the 3's on the bottom. That's what happened in this question. The 3 on the top reduced the 3 on the bottom. 6 divided by 3 is 2. 27 divided by 3 is 9. If I had just not done those, I would have had 2 times 1 times 1. 3 times 3. Reduce it early, don't reduce it at the end. Multiplying across the top now means that this 3 has been reduced to a 1. So we have 1 times 2 times 2 times 1. And we have 1 times 1 times 3 times 3. So a 4/9, about a 45% chance. What if he's going to make all 3 free throws? There's only one way that happens. If this is our entire list of all 8 scenarios, only one of them is a make. So we don't need a coefficient in front of anything. It's just the probability of making times the probability of making times the probability of making, which is 2 to the third. And on the bottom in the denominator, 3 to the third. So 8 out of 27, pretty good chance that that's going to happen as well. And not as high of a chance as the 2/3, I think. I think this is closer to 12 out of 27 if you want to compare him. He's more likely going to make 2 of his free throws and just not make all 3. But he could make all 3, and he's got a good chance at it. Let's continue on with question 2. Susan claims that she can calculate the probability of Walter making free throws more efficiently using combinations. So for determining 3 ways Walter can make 1 out of 3 free throws, she's going to multiply 3 choose 1 and the probability of 1 make. This is a little bit deceptive because this is what she's doing. She's going make, miss, miss. So she's still calculating all of the make. She's saying and miss, miss. Okay, so I want to make sure that that's clear there. She didn't just say 3 C1 and 1 make. She's doing the make and the miss and the miss. Now, if we look at here, 3 choose 1, calculator time says, yeah, that's going to be 3 factorial over 3 minus 1 factorial times 1 factorial. So that's 6 over, 2? And 6 over 2 is 3. That's the 3. So it's right. She did her calculation correct. And it does actually line up with what we did in part B. Maybe Susan's onto something. Maybe Susan's onto something that there's a shortcut that we can now use. We're pushing for a formula. Ultimately, though, does she get down to 2/9? We get down to 2/9? Yep. She's got the right answer. She might be onto it. Let's explore this in the next couple of section of videos. That's what this lesson is all about. Can we use combinations to help us calculate larger probabilities? So stick around. Let's see what we can come up with. Thank you for watching this episode. Page 883 is on deck.